What's up, my algebra students? We are working on exponent test review. Don't be surprised if you hear random noises in the background. That would be my family. This is happening while everybody's awake. So, it's happening. So, right here we got write an equivalent expression for each of the following. Really, that should say simplify, right? We're going to simplify. So here's our dividing rules. So our dividing rules would say that we would have a to the 6th minus 2, because we subtract when we divide things. So that would be a to the 4th power would be our equivalent statement for that one. Okay, number 2 here, we've got a squared raised to the 6th power. So that's power to the power rule. We distribute that guy. So that's going to be a to the 12th, because we do 2 times 6. Here, this is our multiplication rule of exponents. So what we're going to do with this one is we're going to add them together. So that's going to be a to, well, here, we can do a to the 8 plus a negative 3. So that's a to the 5th. Okay. Now this one, these are negative exponent rules. We can't have any negative exponents in our final answers, so we got to make sure that we do that one. I'm going to do this one over here so we got more room. So a to the negative 5th, it's really over 1. Okay, we take that whole thing that's to the negative exponent, we bring that down. It's on the top of the fraction, we got to bring it down. So that's equal to 1 is left on top, over, and then I'll have a to the positive 5th. So that's 1 over a to the positive 5th on that one. Okay, got another multiplication rule, so that's where we're adding our exponents. That's going to be a to the 11th power, because that's 2 plus 9. Okay, number 6 here, we got Kimberly. She incorrectly simplified an expression here. Let's see, we've got negative 5 times, let's see, g to the 3rd, h to the 7th times 4, g to the 7th, h to the 9th. She got this answer right here. So if we look, we've got g to the 3rd and g to the 7th. We would add those together because that's our multiplication rules. That'd be g to the 10th, so that's good. She did h to the 7th times h to the 9th. That would be h to the 16th. Jameson, shh. That's h to the 16th. Okay, so that part's good. Where she messed up was the coefficients. Negative 5 times 4 is supposed to be negative 20. We're supposed to have negative 20 g to the 10th, h to the 16th. So she messed up on the coefficients. So that's this one. She messed up on that one. Okay. These ones, nope. These other ones, she incorrectly combined the exponents of g, nope. Incorrectly combined the exponents of h, nope. She added the exponents. Yeah, she was supposed to add the exponents, okay? So that works. Okay? Number 7. We've got a rectangle with an area of 12x to the 7th, y to the 8th, and a length of 6x cubed, y. Determine the width of the rectangle. Hey, Jameson, if you don't shut up, leave this room and stay quiet. I tried, but you guys are not good. Leave.
I told you, once that's finished, we will play.
Okay, so we need to find that width. Area is equal to length times width. You got to remember that. Okay, so we have a length and we have an area, so we need to find a width. So really, area divided by length is the same thing as width. So what we can do is we can take our area, which is 12x to the 7th, y to the 8th, over, and we're divided by 6x to the 3rd, y. Now y, remember, if there's no coefficient here, it's to the 1st power. Okay? So now let's apply our division rules. Coefficients we divide like normal. So 12 divided by 6 is 2. Okay. X to the 7th over x to the 3rd, 7 minus 3. That's going to be x to the 4th. Y to the 8th over y to the 1st, 8 minus 1 is y to the 7th. So that's our answer right here. Okay, so if we look over here, there we go. There it is. Okay. Now number 8 says which of the following is not equivalent. So keyword here, not. Okay, which is not the same as this. So this would be like the same thing as saying x squared over x to the fifth. That'd be x times x, that's x squared, over x times x times x times x times x. So there's 5 of them there. Oh, hey, that's a. So that's the same thing as a. So nope, it's not that one. Now if we reduce it a little bit, so we would cancel out that one, we cancel out that one. That'd leave us with a 1 on top. And then an over 1, 2, 3 x's. That'd be x to the third. Oh, hey, that's b. So nope, not that one. Okay, if we had something like this, 1 times 1 is a bunch of fractions multiplied together. You just multiply numerators together. 1 times 1 times 1 would be 1 all over x times x times x. That'd be x to the third because there's 3 of them. So that one's not it either. It's got to be that one. That's not equivalent. The rest of them are equivalent to that one. Okay, so that leaves us with working on number 9. Which expression is equivalent to, and then we've got this monster here. We're multiplying. These are multiplying rules. So if we look, first we do the coefficients. We'll do one term at a time. So that's 20 times 5. That's 100. Okay, so automatically that gets rid of b and c. Okay, so that gets rid of that. Let's work on the x's now. I see x to the fourth, and I don't see any x's over here. So x to the fourth. Let's look at our x's. Hey, there's x squared. So it can't be that one. Weird. It must be this one, but let's make sure. Okay. Y to the negative 2, y to the 7th, so we add those. Negative 2 plus 7 would be 5, so that's y to the 5th. And then what do we got left? We've got z to the first power, because that's no coefficient, so 1 plus a negative 3, that'd be z to the negative 2. Now that doesn't look like this, because what they did is they did the one more step. They put that z to the negative 2 into the denominator like that, so it became a positive exponent. But, I mean, as you can see, you can actually eliminate answer choices before you can even need to do that step. So that's cool. Okay, let's just keep moving on. Number 10, which expression is equivalent? Again, we're doing this equivalent thing. Okay, we've got 12p to the 6th, r to the negative 8th. Okay, all over 4p to the third, q to the second, r to the negative 3. So we'll just take that one piece at a time. 12 divided by 4 is 3. So we got the 3. Okay, so automatically, let's see, those are 8s. We don't want 8s. All right, we divide coefficients like normal. What do we got left? So p's. We got p to the 6th over p to the third. So that's going to leave us with 6 minus 3 is 3. So it's p to the third. Q's. I only see Q's on the bottom, so I have to keep them on the bottom. Okay, if it's on the bottom, I have to keep it there. Okay, if there's no others. Let's see, what else do we got left? Well, actually, can we narrow this down? Well, we already know that this Q's got to be on the bottom, so it can't be D. But let's keep going just to make sure. So r to the negative 8th over r to the negative 3rd, so that's a negative 8 minus a negative 3, so that actually becomes plus. That'll be r to the negative 5th. But if we look at our answer, that should be this one. That r to the 5th is on bottom and positive. That's because negative exponents have this guy go down. Okay, so that one works as well. All right, so let's move on to this one. We got an exponential function. The graph shown represents a population of bacteria over time. Which of the following is a not true statement? Again, we got to pay attention to these keywords. We got not. Okay, not true. The initial population was about 50. Well, if I look at this, these squares seem to go by hundreds, so it's about halfway. So I would say it can't be that one because that's true. The population increased by 100 each hour. Well, if I look, here's a counter example right here. Here it's 800 bacteria, and then an hour later over here, it's 1,600 bacteria. That's an increase of 800. So there you go. That's a false right there. Let's just look at the rest of them. Population doubled every hour. Well, it was 800, and then it increased by 800 again. We would go backwards, 400 to 800, so that doubled. Okay, you can keep going. So it wasn't that one. Population at 6 hours would be about 3,200. Yeah, I mean, if we took it another hour out, it would double again. So yeah, that's good on that one. So we can't choose that one. Okay. Which of the following is a geometric sequence with a common ratio of 1/4? Common ratio is just like, it's the rate. It's just like, how is it changing every time? So it's like, what are you multiplying by every time? So if we look, 1/4 would be the same thing as like dividing by 4. So they'd be getting smaller. Every time your rates or your common ratio, it's like a fraction less than 1, that's going to be getting smaller. So I see smaller, smaller, and smaller. So actually, whoa, that one's weird. 16, 4, negative 4, 6. Yeah, no, But then look at this one. This one's getting bigger. 1, 4, 16, 64. Nope, we're getting smaller because we're dividing by 4. Let's see. These ones, 7 divided by 4 would be like 1 point something. But then it like gets bigger again. Yeah, that can't be it. That one. It's got to be this guy. 96 divided by 4 is 24. 6, 1.5. Yep, that one looks good. 13. Myra's savings account balance can be determined by this equation right here. So we've got this exponential function. What does the 3,000 represent? Well, 3,000, remember, when we're talking about our exponential functions, it's y times equals a times b to the x. Okay, a is our starting point. That's where we start. B is our rate. So 3,000 is our a. That's our a. So it's got to be a starting point. So we're looking for, that's our keyword we're looking for here. So annual interest rate. It's not a rate. Interest earned, no. Number of years, no. How about starting? There's our keyword. The starting balance of the savings account. Okay, so make sure that you're looking for those keywords. All right. Number 14, I'm going to tell you right now, this one is a little different from things that we've seen in the past, but let's see if we can work through it. The population of a town of 3,000 increases. So there's a keyword right there. So it's going to be getting bigger by 7% each year over the next 3 years. If the domain is 0, 1, 2, 3, for this situation, representing the years of the town population was recorded, what is the range? So the range is going to be those y values. So increases means it's got to be getting bigger. Got to be getting bigger. So if I look, let's see, B gets smaller. So we can automatically get rid of that one. Now 7%, that is like multiplying by 1.07. It's not very big, so it's not going to get big very fast. So this one right here, this is more than doubling. It's actually getting multiplied by like 7, by literally 7. That's too fast. All right, populations don't increase that fast. Then if we look at C, 3,000, 307, 314, that's a constant increase. That's like linear. We're not dealing with linear stuff here. We're dealing with exponents. It's got to be doing exponents. That leaves us with D. Okay? That's an increase of 7%. It's pretty reasonable. Okay? It's not going to change by the same. It didn't increase by 210 again. It's just going to keep going. Okay? 7%. So it's a little different. Flipping over to the back. I'm expecting on number 15 for my students to get 100% on this question. Which expression has a value of 1? Anything raised to the 0 power is 1. What's raised to the 0 power? D. That's the only one. You better get that one right. I drilled that one into your heads like crazy. Okay? 16. This is absolutely a calculator question. I don't have a calculator at home, but you can see bacteria can multiply at an alarming rate when they increase by 2% each day. If we start with only 3 bacteria, which exponential equations best represents this scenario? So you should be thinking like, okay, it's increasing, so that means it's got to get bigger. Okay, so when you're looking in your calculator, it should be getting bigger. It's not doubling. This is doubling right here when the rate is 2. You're not doubling. Okay? And remember, anytime, since it's increasing, this has got to be bigger than 1. This is definitely not bigger than 1. That would be decay. We're going to be growing. This is growth. Okay? This is growth. So when you're plugging these into your calculator, you should see growth, but just not too much. Okay? This one's not going to be growth because that's less than 1, so it can't be that one. Okay? This one obviously is going to be less than 1. It's 1 minus something. That's going to be smaller than 1. Okay, this is 1 plus something. That's bigger than 1. This is our only one that's growth, but like reasonable. Okay, see, I didn't even need a calculator, but you can always use one too. Here we go. Exponential functions. Here's our function. 3 times 2 to the x power. So our initial value is 3 and our rate is 2. What is the domain? The domain of all of these is all real numbers, or my capital R. Okay? Range, always y greater than 0 every time. Asymptote, every time y equals 0 should be drilled into your brains now. Okay? Every single time. All real numbers, range is y greater than 0, asymptote y equals 0 every single time. Luckily that happens in algebra, but not anymore past this. Okay? Here's another calculator problem right here. Okay, table below models the desktop computer sold near the local technology store. Which exponential regression is used to determine a function for this data? So, we need to find, well, we can at least narrow it down with the starting point, right? There's our starting point because that's our y-intercept, right? So our x equals 0. So we can narrow that down there because that's the wrong starting point. Okay? Then we can take a look at this. Do I ever say this is x minus 1 on that function? No, I do not. It's always supposed to be x. Hey, I didn't even need my calculator. Look at that. Okay? It's b, because there's my starting point. Obviously, my rate must be 0.65, because that's really the only option. But remember, it's not x minus 1 up here. My exponent's always just x, so it's got to be b. Okay? Using the table of values in the problem above, what would the number of computers sold after 10 years? So we'd be looking at x is 10, and we'd be looking for what y would go with it. Now, let's see. Can I do this without a calculator? I don't think I can. So I'm going to have to pause and come back. Dang it. 3/4 of the way I was able to do it without it. No.
He's almost done. Why don't you go get your James done? Because then we'll be able to play.
So but after I get my James done, can I do a class?
Wait, it's 7:30. By the time we play the game, read books, and go to bed, it'll be time for bed. What craft do you want to do?
The ones that you draw a picture, but like the girl things that you put something on it. Okay.
You can do that this weekend. Because. Or you could do it after school tomorrow. You'll be home at a normal time. When you go to CG, you don't get home till late. So by the time you eat your dinner, it's already like time for jammies. So go get your jammies on, and then we'll play this game, okay?
Where's the baby thing?
What baby thing?
The thing that buzzes around, that moves.
Oh, it's in my room. Because when I took a shower today, I put her in there.
All right. cell phone calculator. But let's see if I need more calculators and more things. My calculator's somewhere. Where's my calculator?
The black one?
Yeah.
I don't know.
Oh, I don't need it. Never mind. Never mind. I can do it with this.
Hi.
What's up? Go get your jammies on. What? What? Yes.
All right, I'm back. Here's what I got. Got my cell phone. Just gonna have to work. Zoom out a little bit. There we go. Oh no, where'd it go? There we go. Okay. So here's our rate. We know our rate. Our rate is 0.65. Or wait, no, there it is. 0.65. So that's what we're gonna multiply from one to the next. So see, I can actually prove it. 411 times 0.65 is 267. Of course, it's 267 and change, but they don't care about the change. So 267. So I'm going to continue my table over here, x, y. So I've got 5, 6, 7, 8, 9, 10. So that's what I'm looking for. Okay. So let's see. Need to do that one more time. 267 times 0.65. This would be a lot easier if I had just brought one of these things home, but whatever. 174. Okay, so then I do that one more time. 174 times 0.65. That's my rate. I get 113. Okay, 7. So I got 113 times 0.65. That's 73. Keep going. 73 times 0.65. That's 47. Okay, so then that's 47 times 0.65. Equals 30. I'll round up to 1, so that's 31. And then one more time. That's 31 times 0.67 equals 20. I mean, I would round it up to 21, but if looking at my answer choices, I've got 20, 13, 10, 150. The closest one's 20. So there we go. That's it. Okay? Remember, it's just a pattern. You're just multiplying by the same thing. Jameson Daniel. Okay, almost done. Which of the following represents an exponential function with an initial value of 2, that's my A, and a rate of growth of 3/4, that's my B. So my function's y equals, I got 2 as my initial value, times 3/4 raised to the x. So that's my function. Again, you can use your calculator for this to check yourself, but we've got an initial value of 2, so we need to make sure we have an initial value of 2. That works here. That does not work here. This is a line. Get rid of that. No. Okay. 3/4 means this is going to be decay. So that means we're going to be getting smaller. That's this one. See it? Decay. Okay. So that one's going to be B. Ah, my damn marker died. Seriously, any kids that actually watch this video are going to make fun of me so much.
Jammer, I love the jammies you picked out. They match so well.
Yeah, these are big.
Go put this in the hamper, please.
Alright, purple marker died. Moving on. That last one was B. Okay, we have an exponential function, contains ordered pairs as shown. So remember, this is just exponential functions mean that they have a constant thing we're multiplying by. So if we look, 2 times 8 gets me 16. 16 times 8 gets me 128. 128 times 8 equals 1024. So my rate of growth is 8. Okay? If we wanted to get fancy, we could say y equals my starting value of 2 times 8 to the x power. Okay? Looking at this guy. Here's my initial value, so y equals 13. We need to find our rate, though. Jameson. Okay, 13 times what equals 39? Well, that's times 3. 39 times 3 equals the 117. 117 times 3 equals 351. So my rate has got to be 3. So there would be my function for this guy. But all we care about is just the rate. So that's 3. Okay, so it's just what you're multiplying by to get from one to the next. Okay? The value. There's the last one. Jameson, nobody in my class cares about your belly button hurting, okay? The value V of a certain investment quadruples. There's a funny one. Quadruples. That's a keyword we're going to need to use later. Every month. Which function can be used to find the value of the investment at the end of n months if there is an initial value of 275? So if I was writing an equation here, I'd say, okay, well, my initial value is what comes first times my rate. Now my rate in this case, see this word quadruple, that means times 4. Okay, so that means times 4. So my rate is going to be 4, and that's to the x power. So I'm looking for something with a base of 4 and an initial value of 275. I've got 275. That one's not 275 as the rate, or as the initial value. Let's see. This one's got m in the wrong place, so nope. That one's got an x randomly in there, so nope. It's got to be this one. See, except that they used a v for y and they used an m for x, so that works. And there's your review. Good luck on your test tomorrow.